Like the slide says, my name is Matt Noe. Quick overview of what we'll be talking about today. Like David said, we'll be diving into it a bit greater detail. One of the newer apps on Polaris, specifically Radar, which centers around, like David said again, leveraging the data within the Rubrik platform to provide additional services for our customers. And a quick background on me. I've been here at Rubrik for coming up on 4 years. Spent the early days actually on the engineering side, working on a number of different V1s of the product. Have since transitioned over to the product team, where again, focusing on some of these newer Polaris apps. Prior to my time at Rubrik, I was doing Department of Defense consulting, primarily big data analytics type work. So without further ado, let's get right into it. And so a quick agenda for this presentation. First, we'll kind of talk about some of the background around why it is that we built Radar. Then we'll get into kind of the under the hood, how it is that Radar works behind the scenes. And finally, then we'll switch gears and walk through a product demo, show you what it looks like, what it feels like. And then we'll close out with a bit of a deeper dive on the actual machine learning model that powers Radar and how that's kind of evolved over the course of the product's life. So to start with the background, right? I won't spend too much time on points 1 and 2 here, since you all know what our core cloud data management product does with backup and recovery. And David just spoke at length about our Polaris SaaS platform and how it gives you that unified, centralized metadata management of all of your apps across your hybrid cloud environment, right? So what we started thinking about probably about a year and a half ago, was now that all of this data is under that centralized view, if we were to start looking at that data a bit more, right? We're looking at how is it changing, maybe what's inside of it. What additional services can we provide for our customers? Or put a different way, what additional pain points could we solve, right? And so how we tackled this kind of question was we just went out and talked with a lot of our customers, and we asked them, pretty straightforward, what are your biggest pain points? What are your top of mind concerns? And one thing that came up all the time is security threats are an increasingly top of mind concern for big enterprises. And the main reason for that is the modern cyber threat actor is so much smarter than it has been historically, right? And a big driver for that, and particularly ransomware specifically, it's able to evolve at a much greater frequency than it has been historically. And that's why in the specific case for ransomware, why it's been able to have such great success bypassing all of those traditional security tools that organizations have in place. And so what we started thinking about, and where we see Rubrik and Radar specifically fitting in, is you got to be prepared for the event that something gets through, right? You need to be prepared for IT's worst day. And what we like to call that is the idea of cyber resiliency, right? And what we mean by that is you need to be able to, in the event that something does get into your environment, you need to be able to detect it as quickly as possible. You need to be able to analyze and understand the scope or the breadth of the impact, right? What machines were hit, what users were doing what, and understand exactly what has happened within your environment. And ultimately, specifically for the data destruction type incidents like a ransomware, you need to be able to recover and get your business back up and running as quickly as possible. And so again, this cyber resiliency bucket is really where we see Radar fitting in. Let's see. Looks like my clicker has...
Excuse me, do you keep an historic of the logs?
Go ahead.
Or do you keep an historic of the logs?
The historical logs?
Because you made some prevention, but I suppose that it is because of the logs that you can keep.
Mm-hmm.
But do you keep them? How long do you keep them?
That's a great question. We'll walk through kind of the behind the scenes, how Radar works, and I'll make sure to address that point when we get there. So again, where we see Radar fitting in is this idea of cyber resiliency, right? So we see it as augmenting those existing security tools in place. It is by no means our intention to go out and replace a Splunk or any of those primary security tools. What we are providing with Radar is a last line of defense detection. So if all else fails and it slips through, we're adding that other additional layer. And then we're providing increased intelligence to the user around, what machines were hit, how were they impacted, what happened, so they can analyze and understand the scope of the attack as quickly as possible, and then transitioning seamlessly into those Rubrik recovery workflows, right, to get the business back up and running. So how does Radar work? At a high level, what Radar does is it analyzes the change that occurs on any given system. And it uses that change for the three purposes outlined here. First, it uses it to detect anomalous activity on any given system. Then it'll surface up that change to the user, allowing them to quickly understand the impact of the attack. And finally, again, once the user has figured out what has changed, be able to use that information to ultimately recover the data back as quickly as possible. So now we'll get into some of the actual technical details. So the architecture, what we see here is you have your Polaris SaaS platform connected to a Rubrik cluster running within a data center that's protecting your VMware environment, for example. The first thing that happens is we take a snapshot of a VM and we subsequently index it. And this has been a part of the process from the very, very early days, right? This is how we provide our granular file level recovery, global file search, things like that. What we're doing with Radar is we're taking it a step further. And what we do is after indexing, we compare that index or that point in time to the previous snapshot to determine exactly what changed between those 2 points in time. And then we send that change index describing the change up to Polaris, which is where all of the deeper analysis occurs. And a quick point I'll call out, again, like David said, we want to make sure that the data itself always stays within the customer's control. And so the data actually never leaves the brick. It's only that metadata describing the change that is uploaded into Polaris. So what is the first thing that happens? Go ahead.
Question about that. So the metadata that's being sent up, is that metadata only kept in the context of that one customer, or are you using that metadata across multiple customers to build a training model?
Great question. So we keep the data within the single customer's account. We do have a process of anonymizing the data that we can then use to feed and kind of augment the model. And that's how we've been able to, and I'll get into this in one of the last two slides I touch on how we've been able to kind of enhance our model over time using some of that anonymized data.
Okay. And Radar, is that an opt-in? So
yes.
Okay. Yeah.
Yes, of course. Awesome. So once the metadata gets up to Polaris, the first thing that happens is it's fed into the anomaly detection pipeline. And so what we've done here is we've introduced a machine learning model that's capable of learning that baseline behavior. And so the way to think about this is, with every point in time, we compute various features of change. There are things conceptually like how many files were added, how many files were modified, how many were deleted, so that over time, the model will learn what that normal behavior is. The idea here being, should a ransomware get in, right? Ransomware gets in and it encrypts all the files. It renames them, it deletes, it basically tears up the file system. That behavior deviates very significantly from that learned baseline, and the model will be able to detect that and subsequently inform the user. And again, conceptually, it's things like files added, modified, and deleted. The features themselves are actually a bit more complicated. It's all sorts of different ratios and things like that. And again, those are changing all the time as we iterate on the model. So what happens after anomaly detection? Well, the first thing, obviously, is we inform the user so that they know as quickly as possible, hey, something strange happened on this system. You need to go investigate. Right? And what we'll do next is actually Radar will go and kick off another job on the brick that will look at those changed files for signs of encryption. And we do that looking at the magic bytes of a file or at the entropy. These are industry best practices or industry standards rather for computing entropy encryption. Again, we'll then upload that metadata up to Polaris for further analysis. And the whole idea behind this two-stage pipeline is if all of a sudden you have a lot of file system churn, something crazy happens, and all of the new or changed files are subsequently encrypted, it's a pretty strong indicator that you were hit with something like a ransomware. And again, the user is informed of all of that, and I'll show you that, I think, right now in a product demo. All right, so what we're looking at here is the core Polaris dashboard. And I don't want to spend too much time on Polaris, but I will say, kind of a high level, right? Like David was mentioning, gives you that, unified view of all of your environment, whether it's in the US or maybe in India, all of your clusters, what's happening, are there any failures, how are my jobs doing, et cetera. You get that all in a single immediate glance. But what I want to focus on is the radar piece. So what we can see here is, this specific Polaris account has experienced or detected 2 radar anomalies in the past 24 hours. And so what we'll do is drill into that. So here, this is the first place where you get the information on, what is the horizontal scope of this incident, right? What machines were impacted? And so we can see we have this radar 01 VM and this radar 02 VM that we detected anomalous file system activity, right? So this gives you kind of, again, like I was saying, horizontal, how many machines were impacted. And the next step is really going to be to drill in and investigate a bit further. Oh man, it's all distorted. But basically what we're seeing, let me see if I can expand this out a little bit. There we go, that's a little better. Basically what we see here is, around 5:15 a.m. on April 11th, radar detected a high amount of file system change, right? All of these deletions, all of these creations. And in addition, it flagged a number of these created and modified files as suspicious, right? So this, as well as we can see, we ran that second stage of the pipeline, the encryption detection, and we noticed a high number of indicators of encryption. So the whole intention of this view is to give the user a kind of a quick glance into, is this actually something malicious? Give me a quick summary of what radar detected so that they can make the call on, do I need to investigate further or not? And looking at this.
Can I ask a question?
Yeah,
I'm sorry. Is this, when it says this detection occurred at 5:18 a.m., is that like a real-time detection, or we did a backup at 11 p.m., we did a backup at 11 p.m. the next day, and between those 2 backups, we detected changes?
Great question. And this ties back into what I was saying earlier. It's not a real-time detection tool, right? That's not our intention. It's a last line of defense if something were to slip through all of those other tools and go unnoticed.
I'm sorry. If you said that, I'm sorry. I was taking notes.
No worries.
I was also curious, can a customer consume Polaris without having on-prem Rubrik hardware?
So for radar, no, not today. We only support those on-prem file systems.
Right, so Polaris can do the cloud backups, and it doesn't require but
Yes.
for radar, it is,
Exactly.
okay, gotcha.
So for things like
That's what I
Office
thought.
365, the cloud-native data sources,
Yes.
you can consume Polaris just with those.
Cool, thank you.
Yep.
You guys know your kind of customers, and I can see the scenarios. But for me, if I had 4,000 files that have been encrypted, I don't need this to tell me that. I've probably got a lot of people ringing me up, or like
Yeah.
I'm going to know that's the problem. So kind of, where are you adding that kind of
Yeah.
here?
So let me drill into the next screen and see if it kind of helps. So after you get that first glance, what the next step would be is to go and see exactly those files that were encrypted, right? You need to know what needs to be recovered. And so what you'll do is drill in and investigate, right?
Sorry, just one question.
Yeah.
If I've already backed up a malware attack for 2 days, by the time you've had that window to analyze it and and tell me, isn't it too late? I'm not going to restore 3 days ago.
So Yeah,
Well, you are if it's been encrypted because no one's made any changes to it.
No, not if it's just some of them allow you to continue doing what you're doing. So you could have made changes, they just stay encrypted. So some of the malware that's out there, it has a time bomb effect. So it'll get encrypted. It could be encrypted for months before you notice. There are interesting other ways of this thing's happening. They might wait 72 hours or more before they launch a direct message that you've got a problem. So you could have been working for a few days. And if I've detected it 48 hours later, it could be too late.
So I think for that, it's totally going to depend on, one, how frequently are you taking those snapshots, right? Because that's the ultimate driver for how frequently Radar is able to detect this kind of encryption. So if you have the daily backups, it's going to be at a daily frequency. But if you shrink that to 4 hours or however much, Radar is going to be running on that frequency. And then the retention will also impact what you're saying, right?
Okay.
So if you're retaining these snapshots for the 30-day interval or however long, you'll be able to roll it back to one of those points in time.
I have two questions.
Yep.
Is the analysis doing in real time?
No. So the analysis, it happens, you take the snapshot, and then subsequently you'll do the analysis after that.
Okay, and what kind of action does it engage? Is that only an alerting, or can it engage some other actions like cutting off the access of the files or something like that?
So that is not our area, going in and preventing, right, blocking the attack. That's going to be still the realm of either your endpoint tool or maybe something on the network. That's not our area. Beyond alerting, what we will enable people to do, and that's what this screen is specifically for, is go in and select exactly the files that you need to recover so you can put them back.
Yeah, but in the ransomware attack, the quick action are really fundamental. Mm-hmm. And one way to detect a ransomware attack is a massive changing name files. Mm-hmm. So we really need to take action immediately in this case.
Yep, 100% agree with you, right? And so the real-time detection is just as critical as it ever has been. And Radar is not designed to go and replace those real-time detection prevention tools. It's meant to be a kind of a last line of defense, right? The security best practices of today is, you have a layered security model, right? Where you have as many tools as possible in place, making it as difficult as possible for the attackers to get in. And so that's where we see Radar, and this is really where Rubrik fits, is it's a last line at that kind of data or backup level.
And do you plan to evaluate your product as a first line detect attack, or it is not in your job?
So I don't want to talk too much about futures.
Okay.
We certainly hear these same questions from customers all the time, and so we're thinking about stuff. But again, don't want to go too much into what we'll do in the future. So awesome. Thanks for all the questions, everyone. Circling back again, and it's a shame it's all scrunched up here, but basically what we're looking at here is a comparison or a diff view between the two snapshots to show exactly what it is that's changed, right? So we're comparing the snapshot on the 11th in the morning to that previous day's snapshot, with the idea here to show exactly what changed between those 2 points in time. And let me drill in and just show the interesting things here. We can see this file shares folder. This is where something strange happened, right? This is what, and we'll drill in again just to give an even deeper sense. So what we can see is basically we had all of these, productivity type documents that had been deleted and were replaced with these encrypted variants, right? This is what a ransomware incident is going to look like in this kind of a diff view. And so it gives you just that quick understanding of what happened to my system, right? And so you can look, you'll see, what does .encrypted mean? What kind of ransomware variant is that? You can go and talk with your security team, talk with other industry experts to kind of further analyze the scope and understand the attack. But ultimately, what you're going to want to do here is recover everything that needs to be recovered, right? And so you can just select those deleted files, and then transition, and this should look very similar to the existing Rubrik recovery workflow. So basically you select all the files that were deleted, can go in and place them back where they were previously, or you can stick them in an alternative folder or something like that. So the whole idea of the flow is, in the event something does slip through, you understand, or we detect it, and then you understand the impact, and ultimately are able to recover as quickly as possible.
Can I ask why on the page before you selected deleted rather than suspicious? Because, I mean, in that time, there would have been files that legitimately would have been deleted.
That's a great question. And so the reason I selected deleted for this is that, we want to recover primarily those deleted files. And you're absolutely right. If someone did go in and delete something intentionally, you're probably going to place those back. But in the event of some kind of destructive ransomware incident, rather avoid data loss, and maybe you put something back that people want to delete.
But if you've done the analysis on the snapshot and you know the files have been encrypted, so they're not necessarily deleted, it's those ones you'd want to recover.
So you're saying the tying the deleted to the encrypted variant.
Yeah.
That's a great feedback. We don't do that direct tying right now. All we're doing is basically the deleted files versus now there's a bunch of new suspicious encrypted variants. We don't tie this file is deleted and replaced with this variant.
What you're saying there is an encryption is a kind of a delete and then recreate.
Yes,
So
exactly. To our indexing system, how we visualize that is the first file was deleted and a new file has appeared that is encrypted and was deemed suspicious. That mapping is not there. All right, so let's talk a little bit more about that machine learning model that we built. So this was the first machine learning product Rubrik has built. We learned a ton over the past few months with it running out in production. And I got to give a shout out to the team. It's a bunch of very, very smart data scientists and machine learning engineers working on this for the past many months. And they've done quite a bit to evolve the model over time. And that's what I'll walk you through, kind of the 3 phases the model has taken. So we started out with a k-nearest neighbors model. And the main reason for this is we didn't have that much real world data, right? You typically, when you come into a machine learning problem, you want a large data set of pre-labeled things that you can feed and train the model off of. We didn't really have that. We were able to simulate and generate our own in-house data points, but we only had kind of a limited set. So that's why we opted for this k-nearest neighbors model. And again, we still needed, despite the lack of a huge training set, we needed high accuracy right out the gate. And what we did was basically, we came up with a few features that we thought conceptually made sense, and we were able to go in and kind of fine tune those as needed. And that was the first few months of Radar out in the wild. And then the next phase, as we started getting that additional real world data points, and again, we ran this through all of these, the anonymization tool that I was talking about earlier, we switched over to a random forest model, which the benefit here is when you have those more data points, the model will, and we were able to go in and label them as non-ransomware, ransomware, we were able to trade a random forest model that was a bit more accurate. And this, how we did that, we just increased the number of features and let the model itself kind of learn across those higher data points. And that's kind of actually I'll wait to say that until after the 3rd phase, which we just recently switched over to a neural net, which, I'm sure you all have heard neural nets. That's kind of the hot ML technique nowadays. But the big thing about neural nets, to really be effective, you need a lot of data to go in and train these things. And now that we've been running and we've had a fair amount of anonymized data, we were able to train a neural net effectively. And the benefit this gives us is, 1, it's going to be the highest level of accuracy. And 2, and how it works is we basically just compute a large number of features, those ratios that I was referring to, and throw them into the neural net. and the model itself is able to learn, the correct weights. And so that's one thing you can kind of take away is the evolution of this model is basically went from little amount of training data to a large amount of training data and few features to larger features. Go ahead.
I'm curious, as you've trained the machine learning model and discovered new potential dimensions for or features or whatever you want to call them.
Yep.
I mean, ransomware is one obvious direction. Have you discovered any other less obvious applications that might not even be security related? I mean, give a potential example. Let's say someone's planning on leaving a company really soon, and so they start copying all of the documents that are related to them off a file share onto their local computer. That looks pretty suspicious. Is that something your model might pick up on?
Yeah, absolutely. And I'm really glad you actually asked this question. So that is 100% a use case, right? The disgruntled employee on his last day, because the model is really just anomaly detection, right? It's not ransomware detection. And so the malicious deletion from a user, something like that, is one use case. Another very interesting use case is, I call it more a operational recovery use case, where someone goes in and writes a script that accidentally deleted 75% of a file system, right? These are the reasons why people go in and recover on a day-to-day basis. Radar flags that, right? That's an abnormal deletion, an anomalous event. And so the backup guy, gets a radar alert and is able to proactively reach out to some business application team and say, I noticed all of this deletion or all of this change on your system. Was it intentional? That makes the backup guy look really good, right? He knows when you made a mistake and is able to proactively recover.
Are you correlating information between multiple systems? So you've got some on-prem systems, you got something running in Azure, that's something running in AWS. Is there any correlation happening between all of that information?
Great question. Not today.
Okay.
Not today. Today we've been hyper-focused on just make it work very well for a single system.
Okay.
Across the various single systems.
Okay, and it's not looking at Office 365 at all?
Not today.
Okay.
Awesome. So, last thing here. So we recently wanted to really run ransomware or Radar's detection model through the meat grinder and see how it fared against some known ransomware samples. And so we ran an experiment where we basically ran Radar's detection model against some of the most well-known ransomwares. You can see Cerber, CryptoLocker, Locky, WannaCry, really the big name ones, just to see how it performed, right? And obviously we took extra caution when running live ransomware. It was all in isolated network, nothing going in, nothing going out. And the model fared extremely well against these ransomware variants. And you can see the results, pretty much all of those were able to detect with 100% confidence. And there's some statistics about the actual training, validation. That's how you'll build a machine learning model is typically you'll train it on a very large data set, then you validate that it hasn't been overfit to the training set, and ultimately you run it through the testing data set. And that's those numbers you can see there with pretty high accuracy ratings.
Isn't that kind of biased training? Because you know exactly what those things do and what you're looking for. Mm-hmm. How do you know that's going to work in the future when I change the behavior of malware?
That's a great question. So if the malware, the behavior is similar, which most of these ransomware variants have pretty similar behavior, they're doing that. We're pretty confident we would flag those, but who's to say what the next evolution is? But again, we wanted to just put it to some of the known ones that organizations are getting hit with most today.